Welcome to Third International Web Conference on Forecasting. Let me briefly introduce myself. I am expert at Turkish Statistical Institute and have PhD degree on agricultural economics from 19 Mayıs University. Today, I want to present the causal relationship between temperature change and food indices in the world. The scope of my presentation can be introduced in 4 parts: introduction, material and method, results, and conclusions. Introduction. The agenda of this century has considerably focused on the climate change and its effects on different sectors. Temperature change is one of the most susceptible indicators of climate change, and agricultural sector is one of the most fragile sectors against temperature and climate change. For this reason, the studies on the effects of climate change on agricultural sector are very essential to analyze the sustainability of agricultural sector. The objective of this study is to analyze the relationship between temperature change and production price indices of food in the world for the period of 1990-2016. Now we can look at the material and methods of the study. The title of the study is the annual time series data of food price index, gross production index of food, and temperature change for 27 years period from 1990 to 2016, and it was obtained from the databases of Food and Agricultural Organization. The methods of the study are Johansen cointegration method and Granger causality test. Johansen cointegration method is a method for both determining how many cointegrating vectors there are and estimating all the distinct relationships. If there are n variables which all have unit roots, there are at most n-1 cointegrating vectors. In Granger causality test, there are more than 2 time series, and the relationship among the series is analyzed through the direction of them. The coefficients of the variables will be statistically significant if the causality is available. EROGLU 8 and RStudio were used in order to analyze the data. Now we can look at the results of the model. The figure reports the time series graph of PPI, GPI, and temperature change, and highlighted that GPI has shown an increasing trend over the period 1990 to 2016, whereas PPI and temperature change has shown fluctuations in time. The autocorrelation and partial autocorrelation graphs indicate that 3 time series are non-stationary at level. Therefore, augmented Dickey-Fuller test should be applied in order to decide whether the series have unit root or not. Augmented Dickey-Fuller test results report that we cannot reject the null hypothesis of unit root in the series, and they are non-stationary. However, all of them are stationary in first differences, and the null of a unit root in the difference of the series could be rejected. Therefore, the series are I1. The results of the Johansen cointegration test with trace and max eigen statistics indicated that FPI, GPI, and temperature change are cointegrated. Therefore, the null hypothesis of non-cointegration was rejected at the level of 0.05 significance, and there is long-run relationship among the series. Granger causality test results indicated that there is bidirectional causality between GPI and temperature change. and unidirectional causality runs from FPI to temperature change. Let me introduce the conclusions. The co-integration of the theories indicated that temperature change moves with price and production indices in the world. The bidirectional causality between GPI and temperature change indicated that not only temperature change affects the agricultural production, but the quantity and quality of production also led to temperature change. For this reason, the agricultural sector should be regulated via policies which take sustainable and environmental development into consideration. By the way, the food production and environment could be considerably well managed. This study revealed that temperature change is the key indicator of sustainable agricultural production. Thank you for your attention.